You know that feeling, right? That frustration when an AI agent seems like a genius one second, and then it just completely falls apart the next. Well, today, we're going to fix that. We're diving into a blueprint from Mark Tech Post that promises to turn these fragile AI toys into bulletproof tools you can actually, depend on for real-world stuff.
So here's how we're going to break it down. First, we'll get real about the problem. Why are so many of these AI agents so flaky? Then, we'll get into the good stuff, the blueprint for a better way. We'll peek under the hood at the core components, see it all work in action, and then we'll wrap up with why this whole approach could be a massive game changer for anyone trying to use AI for serious work.
All right, let's get right into the heart of it. We've all seen those mind-blowing demos, but then when you try to use these agents for an actual job, they just break. It's this gap between the promise and the reality that we're going to tackle head-on. So why are these incredibly powerful tools so darn fragile?
I mean, we've all been there. An AI agent writes this amazing, creative piece of text, and then in the very next prompt, it totally misunderstands a simple command. Or, and this is the worst part, it just fails silently, leaving you wondering what on earth went wrong. That kind of unpredictability, it's the biggest roadblock to actually trusting these things with anything important.
Okay, so this slide really puts the problem in black and white. On the left, you've got what most AI does today, its best effort. It tries hard, but the results are unpredictable, unstructured, and, fragile. But on the right, that's the goal. That's the bulletproof workflow. We're talking predictable, strictly structured, super reliable, and, this is key, it enforces validation so those silent errors just can't happen.
So if that's the problem, then what's the solution? Well, this brings us to the whole philosophy behind this Mark Tech Post tutorial. It's a blueprint built on one core idea: enforced reliability. This is a huge mindset shift, moving away from just hoping the AI gets it right to guaranteeing that it does.
The very first pillar of this whole thing is what's called strict schemas. Now, the best way to think about this is like giving the AI a contract. It's a non-negotiable fill-in-the-blanks form that it absolutely has to follow. It lays out exactly what the output needs to look like so you get predictable, perfectly structured data every single time. No more guesswork.
Okay, pillar number 2 is tool injection, and this is all about control. Instead of just letting the AI run wild and try to invent its own ways of doing things, you hand it a very specific pre-approved toolbox. It's kind of like giving a chef a knife, a pan, and a spoon instead of just letting them loose in a hardware store. It makes sure the agent only talks to the outside world, like your database, in a way that's totally safe and controlled.
And this third pillar is absolutely crucial if you're thinking long-term: model-agnostic execution. Basically, it means you build the brains of your agent, the rules and the tools, completely separate from the AI model itself. Why is that such a big deal? Well, it means you can swap out one LLM for a newer, better one down the road without having to tear down and rebuild your entire system. It's all about flexibility and not getting locked in.
Okay, the philosophy sounds great, but how does this all work in the real world? Let's switch gears from the why to the how and actually look at the nuts and bolts of building one of these super reliable agents.
So how does the magic happen? It really boils down to 2 key ingredients from the tutorial. First, there's a tool called PydanticAI, and that's what helps us create those strict contracts for the AI. Second, there's a concept called dependency injection, which is just a fancy way of saying we're safely handing the AI its approved tools, kind of like giving it the keys to the car instead of letting it hotwire one.
So what does the actual process look like? Well, it's kind of like a 4-step dance. First, you define your data models. That's your contract. Then, you get your tools ready, like a database connection. Third, you assemble the agent, basically introducing it to its official toolbox. And finally, and this is the most amazing part, you run and validate. The agent does its job, and then it checks its own homework to make sure it followed all the rules.
All right, let's see how this all clicks together. This is where the theory hits the road, and we get to watch the agent in action, going from a simple request all the way to a perfectly validated result. And this quote from the article, it just says it all. The agent can self-correct. Just let that sink in for a second. This isn't an AI that makes a mistake and then just crashes. It's an AI that recognizes its own mistake because its output doesn't match the rules we gave it, and then it tries again until it gets it right. This is a world away from how we normally handle errors. The system is designed to be resilient and to fix itself.
So here's the play-by-play. It all starts with a user asking to create a support ticket. The agent figures out, okay, I need my create ticket tool for this. It uses the tool, talks to the database, and then here's the magic: validation. The agent literally checks its own work against the rulebook, If it messed up, maybe it forgot a piece of information, it doesn't just give up. It goes into a self-correction loop and tries again and again until the output is perfect. Only then does it give you the final result.
So what's the big picture here? Why is this such a fundamental shift? Let's talk about what this really means for using AI in high-stakes, real-world situations.
So when you pull it all together, what have you got? You've got AI interactions that are predictable and safe. You have automatic error recovery, a system that can literally heal itself, and you've got a future-proof setup so you're not chained to one AI company. At the end of the day, this whole approach builds a bridge right over that reliability gap that's been holding AI back. It gives us a solid foundation for systems we can actually finally depend on.
And that really leaves us with this one huge question. This approach isn't about just building another cool demo. This is about applying real engineering discipline to AI. And it suggests that maybe, just maybe, by enforcing these rules in this structure, we're at a turning point where we're finally ready to build AI that we can truly trust with our most critical work.